Welcome, my name is Taylor Stein, Fusion 360 Evangelist, and in this webinar we're going to be taking a look at how to work with imported models inside of Fusion 360. So the goals for today's webinar is really to take a look at how do we upload files to Fusion 360, how do we work with neutral file types, what's the difference between solid files, surfaces, meshes, and what can Fusion 360 do to those file types and what might be different between them. And also I want to show how we go about importing an existing assembly and how we work with as-built joints to really save us a lot of work along the way. And as you can see on the right hand side, this is a list of all the files that we can import into Fusion 360. So it can feel a little bit overwhelming at first, but I'm here to show you that it is not too hard, and there's some very simple things that we can do to import geometry that you might have from other CAD tools that you're using or other resources, maybe an online library of 3D parts that you're working with. So with that, I can jump right into the tool. So let me switch over to Fusion 360. And the first example I want to show is how do we actually go about importing data into Fusion 360. Because Fusion 360 is a cloud-based tool, most of the files, they do have to be uploaded to Fusion 360 in order to work on them. To do that, all you have to do is open your data panel in the upper left corner over here. Navigate to any project that you like, or just simply go to your recent data, and then click this Upload button. In the Upload dialog window, you can select any file type that you wish to upload and translate to Fusion 360. So I can click Select Files, and here's a list again of all the file types that you can upload and translate to Fusion 360. You'll see everything from neutral file types like IGES and STEP to other existing CAD tools such as Rhino, SolidWorks, ProE, any sort of thing like that. So once you choose your file, you'll be asked to choose a project to upload it to. I can upload it to a project that it's selected here, or I can choose a different project, or even create a new project on its own by clicking this plus project button right there. So once you've selected a file to upload, it'll go ahead and upload it to Fusion 360 and translate it for you, and once it's done translating, it'll appear right here on the left-hand side in your data panel. So that's really all there is to uploading files to Fusion 360, and the first example I want to cover as far as neutral file types is how we work with files such as STEP. So STEP is a neutral CAD file type that really is a solid piece of geometry that you'll be working with. So in this example, I have this bracket that I've uploaded and translated. It was a STEP file type, and I can see that if I open the bodies folder, I have one solid body here. So this is one solid. You'll also notice that after I upload and translate a STEP file, I don't have my timeline on. So by default, we're working in direct modeling mode where the timeline is turned off, and I'll show you how we can turn that on if we wish to. So one of the great things about working in direct modeling mode without the timeline is the ability to do quick direct modifications to the model, and this is mainly done with the press pull command. So with this bracket, there are a few things that I can do to modify it. Under Modify, I can choose Press Pull or press the Q hotkey. And now with this Press Pull command, I can offset surfaces, I can fillet edges, I can change the size of holes, and so forth like that. So if let's say I wanted to go ahead and move this entire face up or down, I can select that face, perform a new offset, and I can offset this up or down. If I want to offset it by 2 millimeters, I can do that and hit OK. And now we've offset that face. Let's say I want to go ahead and remove these two cutout portions here. I can hit Q again to start press pull, and I can move this face up and down. If I click on this existing face, it'll match it to that surface. I can even hold on Mac Command or on a Windows machine Control, and I can add this face to the selection, and now both of them are moved up to that existing surface. And if I hit OK, you'll see that those features are removed. I can also remove features by selecting them and hit the delete key, so there's a lot of things that you can do to manipulate the geometry in a direct way. Additionally, I can hit Q again to choose press pull, and you'll see that if I select an edge, it starts the fillet command. I can add a slight fillet here. So there's a lot of things that you can do in direct modeling mode like this, but there are times where you do want to turn the timeline on and start capturing the features that you're doing to an imported piece of geometry. So to capture design history for an imported part, all you have to do is right-click at the top node of the browser, In this case, it's the file name right here, so I'll right click, and I can choose Capture Design History. What happens is everything that I've done up until this point is essentially flattened into this base feature component or feature down here. And now any subsequent features that I do will be captured in this parametric timeline at the bottom. So if I wanted to create a sketch on this existing face, I can do that. If I wanted to draw a construction line across the midpoint, I can draw that. And let's go ahead and put a circle right here in the middle, and we'll dimension it to, how about 6 millimeters. I can stop my sketch, choose Extrude. Let's go ahead and extrude down to this bottom surface. And now we've performed a cut, creating that hole right in the center. And as you can see, before all the operations that I was doing, I didn't have a timeline for them to be captured in, but now with the parametric timeline, everything is captured here at the bottom. And if I need to make any changes, for example, changing that sketch, I can right-click on that feature and choose Edit Sketch. And I can go back and make a change. If I want this to be 5 millimeters, I can type that in, hit Stop Sketch, and my downstream features update. So those are some of the simple changes that you can make to an imported solid body. Again, you can use press pull to move faces around, add fillets, and create new offsets. And additionally, you can turn the timeline on to start capturing the design features that you're using and create a workable parametric model. Now, a step file isn't the only type of CAD neutral file that you might be working with. There also is a IGES file, which is really a surface file that's really popular as well. So you might find yourself downloading an IGES file, and those work in a little bit of a different way. And what I also wanted to show with this example is another way that you can open files actually locally from your machine. So Fusion 360 does allow you to create a new design from an existing file that you have locally on your computer. And to do that, under the File menu, you'll see that there's a New Design from File option. So if I choose that, I can choose a local file, creating a new Fusion 360 design off of that file, and I can choose whether or not I want to save it. Now this is a shorter list than what can be uploaded and translated to Fusion 360, and that's because we have these local translators that can translate these files locally and don't have to go through the translation on the cloud. So you'll see that in this list I have IGES. I can go ahead and select this bracket as a .igs and hit open. And now what happens is we have a new Fusion 360 design, and it's gone ahead and imported that geometry for me. An IGES file, as I mentioned, is really a lot of patches and surfaces. So if I open up this item details here in the browser, you'll see that this body is made up of 51 unstitched patches. So this entire piece of geometry is broken down into all of these infinitely thin sheets, or what we call surfaces. Now, if I want to work in a surface modeling environment, I can switch from model to patch, and now I have some surface modeling tools. So if I do want to work with this as a complete surface and I want to sketch and extrude some lines and create surfaces and use tools like trim, I can completely do that. But often we see that people want to work with this IGES file as if it is a complete solid. And to do that, all you have to do is stitch together all of these edges between the surfaces, and when you create a watertight solid body, it'll turn it into a solid body inside of Fusion 360. So you see that I have these 51 unstitched surfaces. If I choose under Modify Stitch, I can select all of these surfaces and I can click and select them, or I can drag a window over all of them and save all of us a lot of time. And you'll see that all of the edges that are going to be welded together and really stitched are highlighted in green. And if you're missing some edges, maybe the translation didn't really go so well from the other tool that you're using, you can increase the tolerance here. But just know that as you increase the tolerance, the more the Fusion 360 is really kind of roughing those transitions between the surfaces. So ideally you want to keep this at 0.01 millimeters, and everything looks great. And you'll see that the operation is set to new body. So when I click OK, all of those 51 surfaces are stitched together and I'm left with this solid body. And I can work with it just like the last step file that I showed you. I could choose Q to start press pull. And if I want to change the size of this hole, I can choose this interface. And I can make it larger or smaller. Just like before, if I want to turn on the parametric timeline at the bottom, I can right click at the top and say Capture Design History. And now any features that I use from this point moving forward will show up here at the bottom of my timeline. Another thing that I really like about working with these local files is that it creates a new Fusion 360 design, and I can simply, if I don't want to work with this, I can close it and hit Don't Save. When I'm uploading files to Fusion 360, I have to delete them, but by creating a new design from a local file, if I don't want to work with it and I'm just checking out what a file is that I downloaded from online, I can simply open it, investigate it, and then close it, and don't even save it if I don't want to. So if I switch back to the presentation, we've taken a look at how to upload files to Fusion 360, choosing them and translating them to a workable solid that we can work with. We can also work with neutral file types like solids, like a step file, or surfaces such as an IGES. And surfaces can be stitched to create a solid, and then those are very similar to each other. Also for neutral files, I would say mesh geometry. So often you're working with geometry that's maybe an OBJ or an STL file. And this is when the design is broken down into a lot of small, either triangular or quad-based meshes. So I have an example that shows what we can do with meshes inside of Fusion 360, and that's different if they're triangular or quad-based mesh. In this example, I'm working with triangular-based mesh. So this is a 3D scan of a femur, and if I zoom in really close, we can see that this entire body is made up of thousands and thousands of small triangles. So it's a triangular-based mesh. And the key difference here is that triangular-based mesh, we can't do anything inside of Fusion 360 to translate this into a solid model. All we can do is really reference it and manipulate bodies about the mesh geometry, but we aren't able to come in here and make any direct changes to the mesh or perform any Boolean operations with the mesh. All we can really do is reference it with other tools inside of Fusion. Now to insert a mesh, all you have to do is under the Create menu, choose Create Base Feature, and inside of a base feature I can choose Insert, Insert Mesh, and I can grab that OBJ or STL file. So I'll go back, and here we have our mesh. And what we can do inside of Fusion 360, and it really depends on the geometry that we've imported as the STL, is there's a really interesting command inside of the Sculpt workspace that allows me to snap down T-spline points onto an existing mesh. So to show you how that works, I'll go ahead and create a new form. And now inside of the Sculpt environment, I'll create a cylinder. And I'll create this cylinder on this work plane. And it doesn't really matter the size. I'll make it 80 millimeters in diameter, and I'll click. And let's set the diameter to 80. Let's set the height to 100. And let's have it be symmetric. And now before I hit OK, I can really dial in the number of faces that I have either around the diameter or along the length. And because what I'm going to do is snap down each of these vertices down to the nearest point on the mesh, I probably want to have more vertices to work with so that I have a more accurate pull down to the surface. And this really is a balance. You don't want to have so many that you're computing an unnecessary amount of them, but you want to have enough that you can accurately capture the geometry. And this really varies from example to example. So in this case, I'll have 10 faces going around the diameter and 10 faces going down the height. So we have 100 faces here that we can snap down onto the mesh. I'll click OK. And now what I can do is under the Modify menu, choose Pull. And what Pull lets me do is, if I hover over it, it says Snap Selected T-spline Vertices to a Face or Surface. And I'll choose that. And what it's going to do is pull these down to the nearest point on the mesh. And I can, again, select these individually. Or if I want to do it a lot faster, I can do a window selection over all of the points. And you'll see that they're snapped down onto the mesh. You'll see I can see slight points where the T-spline is lower or higher than the existing mesh, and that's because I only have 100 faces that I'm snapping down onto the mesh, so it's not going to snap perfectly, but it really is a quick way to capture some of this geometry if you're working with select shapes as far as the mesh goes. I'll click OK, and now I have this T-spline body. If I hide the mesh, you'll see that I have this T-spline that I can still work with just like any other T-spline body. If for some reason I wanted to move these around, maybe it's not the best example with a snapping down to a femur, but I can still grab these faces and move them around. So just to demonstrate that, I can select this face, And let's go ahead and translate it this way. So it's just like any other T-spline that I'm used to working with. What I can also do is thicken this. So if I wanted to thicken this geometry, I can click Finish Form. And now under the Create menu, I can choose Thicken. And I'll thicken this, and I can specify thickness. So how about 2 millimeters? And if I wanted to go in, I can type in -2 and create a new body. So I performed the thicken outside of the sculpt environment. That way, if I need to change this thickness down the road, all I have to do is right-click on this feature and choose Edit. What I can do is also apply an appearance to this T-spline and now solid body. So I'll just apply a glossy red material so that we can see really where it differs from the scan. And you can see that it really is accurately, to a certain level, capturing that geometry. And one thing to note is that this is going to work really great with smooth surfaces like this. If you have a mesh with a lot of internal cavities, the pull command is going to have a lot harder of a time snapping down to the mesh. So you do have to be selective as far as which pieces of geometry work well with pull command and which ones do not. What I can also do is maybe if I don't want to thicken this sort of T-spline geometry, I can go ahead and delete that feature. If instead I wanted to cap it off on both ends, all I have to do is under Model, go to Patch, and I can create a patch on both of these ends. So I'll create a patch there, and I'll create another patch on this side. And just like when I imported the IGES file, you'll see that I have 3 surface bodies, and I can choose Stitch, and choose these 3 bodies to stitch together. And I'll click OK, and now we have that solid body. And one little trick to know, and this works with any T-spline, is because the surface environment is parametric, if I go back to the T-spline form, and I'll actually roll the timeline back to this point, if I go back and edit that T-spline form, and maybe I move some of these vertices around, so I'll make this taller like that. When I hit Finish Form and now progress to the timeline, you'll see that these features are updated parametrically. So now I can go through them, and my solid is updated. So I don't have to redo all of that work because these are parametric features that are being layered on top of that original T-spline. So that's how we can use the pull command to really almost shrink wrap some portions of scan geometry. And again, this is for triangular mesh. If you have quad-based mesh, what you can do is if you right-click on it, under Modify, there's an option for Convert. So if I go to my Create Form, there's an option to convert geometry. And if you have a quad-based mesh with under 10,000 faces, it can convert each individual face of the quad-based mesh into a quad that is a T-spline, and then you can have a T-spline that you can turn into a solid body. And there's a YouTube video on this that I'll go ahead and link in the description as well if you're interested in seeing how that works. Let me switch back to the presentation. So that's what we can do with mesh geometry. So we've covered how to upload, how we work with neutral file types, steps, IGES, STL, and OBJ. And actually the last thing that I wanted to share is how we work with existing assemblies. So inside of Fusion 360, if I were to upload a design, if I choose Upload, you'll see that there is an option for an assembly. So let me go to choose the file. And under File Types, you'll see that I can actually import a SolidWorks assembly or an Inventor assembly. So all you have to do is choose the assembly file and all of the child parts associated with the assembly, and it can be imported. In this example, I have a step, but it's going to work exactly the same way. So for the step file, I'm actually just going to open that locally. So do that again to create a new design from that file. Under the File menu, I'll choose New Design from File. And I'll choose this step file and hit OK. So now it's going to bring in that step, and just like if it's an assembly, I'll have these 3 components right here. So I have one for this gear, one for this gear, and one for the base. And sometimes your geometry might be flipped, and that's based on the coordinate system inside of Fusion 360, which direction is up inside of Fusion versus which direction is up inside of the tool that you might have used before or in the tool that was used to create the geometry that you've imported. So in this case, a quick fix is you'll see that when I click on front, that clearly isn't the front view. So what I'm going to do is move the view cube until I am looking at the front, and then right click on that face and choose Set Current View as Front. So now my front orientation is accurate. And to set the home position properly, I'll move to this corner, and I can right-click and choose Set Current View as Home, and now my home position is set just like that. So now we feel a little bit more at home with the geometry, and we have it in here. One thing you'll see is that I have these three components right here, and with the parametric timeline off, I'm not able to move these components around by clicking and dragging on them as I am able to do with the timeline on. So to capture the design history, again, I'll right-click at the top of the browser and choose Capture Design History. So now you'll see that I can move these parts around and move them wherever I want because I don't have any joints set up. So I'll revert back to the original position that I imported them in. And what I wanted to show in this example is how to create assemblies when your parts are already in the exact position that they need to be. So in this example part right here, both of the gears are exactly where they need to be on the axes of the base. So I don't need to use the joint command. What I should be using is the as-built joint. An as-built joint really creates an assembly based on how everything is currently laid out, which is exactly what I have here. So to do that, I'll choose as-built joint. The two components I want to build a relationship between are this revolving component here and the base. And I can choose the motion type. In this case, I'll choose revolute. And I need a point of reference to revolve around. So I'll zoom in and revolve around this point right here. And we'll see that's what we want. And before I get any further, I'll also ground the base to make sure that doesn't move anywhere. So I can right-click on the base and choose ground. And to now test the mechanism, I can move it around and see that that's behaving just how I like. And next I can create another as-built joint. So I'll choose Assemble, As-Built Joint, and I want to join this component and this component. And again, I want revolute, and I want to revolve around this axis right here. So that looks right to me. So as-built joints are when you want to add joints to the way that a assembly is laid out as it already is. The regular joints command is used for if your parts are scattered around and not in the position that they need to be. So now you'll see that I can manipulate these components and move them around how I need to, and you'll see that the mechanism clearly isn't working, and that's because Fusion 360 isn't always detecting collisions. If I want to detect collisions, all I have to do under Assemble is choose Enable All Contact in this case, and Fusion's going to look at the contact between all the components and calculate if there are any collisions and solve how the parts can move together. So I can drag this component around, and you'll see that as it comes in contact with the other one, it solves in the way that it really is set up to solve. So it knows that both of these components can only rotate around, so I can use this to test this simple mechanism just like that. And this is really useful for testing small mechanisms like this, or also for testing if you have parts that are fitting together. So maybe you have a lid that you're closing and you want to make sure that it actually closes properly and doesn't get stopped early, or if you have parts that are sliding into another part and you want to make sure that it doesn't bottom out before it reaches the bottom, you can test that. And there's a lot of different things that you can do with the contact sets inside of Fusion 360. So that's the example of how we can work with imported geometry, capture the design history, and then set up the joints using as-built joints when everything is already in the correct position. So if I go back to these slides, that is actually everything that I had for working with imported geometry. If you're watching this after the fact and this is recorded, if you have any questions, please leave them in the comment section below, or you can reach out to me directly on Twitter at Taylor_Stein. And that's going to wrap it up. So thank you, everyone.